Now, the first option will try to understand about the layer 2 marking. Now, the layer 2 marking is about the traffic as it moves from switch to switch in the form of 802.1q frames, the trunking concepts, the 802.1q frame as it moves over your layer 2 switch network. And when you're implementing some VLANs, we use this. You know the concepts of trunking and other stuff. Now, in that, you will see there are some 802.1q header, which is present. And it includes 2 bytes and 2 bytes. Total, there are 4 bytes of header, which will be added. And again, there is something called this TPID value. Now, this value indicates, generally, it will be like 80x8100. That represents that this particular header is carrying the 802.1q tagged frame. So anyway, this has nothing to do with the marking here. So we are not going to use this. But whereas the other field, what you see here, there is something called this field. Now this field is going to be 2 bytes. 2 bytes means around 16 bits. Now in this 16 bits is composed of again 3 different fields. And that's what you can see here. We are talking about this one. So this is total 16 bits. 2 into 8, and in that we have again 3 values, 1 2 3. The first one, now we are more bothered about this first one. This is what we call as priority bit or priority code, priority code field, and it is going to be 3 bits. Now this value is going to carry the marking value. So this is your actual marking value. And other options like this is actually a discard eligibility bit, which is going to tell whether the traffic should be dropped or not. That's what, in case if there is any congestion. And this is a VLAN ID. VLAN ID is nothing but it carries the VLAN information. And you know the VLAN configuration, the VLAN information it is going to carry. So let's try to see here the first field. Here in this diagram, as I said, we will be using this priority field. Now this priority field is going to be 3 bits, which means if you write the binary values of these 3 bits, you can write in 8 different combinations. So this is your binary combinations. You can write 0 zeros like this. So based on this, you will get the values in the range of 0 to 7. So which means typically we call this as a Qos value. Qos value is nothing but the layer 2 marking value, we call it as. And this class of service value, the Qos value range will be given from 0 to 7. Whereas the 7 is considered as high priority traffic, whereas the 0 is considered as the least, or we can say the least priority traffic. So the values can be given from 0 to 7. That's what the options here. And again, as I said, this particular field is going to be used to mark your packets belonging to which quality of service marking option. Means we can select any one of this. Like let's say if I'm sending some kind of VoIP traffic, I'm going to give the marking value as 5, which is considered as high priority traffic. Or if I'm carrying any FTP traffic, I'm going to give the marking value, let's say 1, which is considered as like kind of best effort traffic or best effort option. So we can decide these marking options. Okay. So we can use these marking values as they move from switch network. These Ethernet frames can be marked with any of these values, where I said 0 is considered as the lowest priority and 7 is considered as a higher priority values. Now in this, again, in terms of marking, we'll be using the values from 1 to 5. This is something only used, whereas the 6 and 7 are reserved for control traffic. Just like your STP messages or VTP messages. Now these are typically your high priority traffic. So most of the time when you are carrying any high priority traffic, okay, so probably your control plane traffic. Now this is like a control plane traffic. like STP, VTP, they automatically categorize into these two. So that's the reason most of the time when you're doing the marking, you never use these two values. And the values which will be used will be from 0 to 5. So one is the default, which is the best effort, and 2, 3, 4, 5. And most of your voice and the video traffic will be using 4 or 5, depending upon the latency and jitter. This is just an example, and these are the technical names what they actually refers to. So this priority field is going to decide the priority for that particular traffic. The higher the number, the higher the priority. Now, similar way, you have one more field, not commonly used, but this field is going to decide whether that particular traffic is eligible for dropping or not. Because whenever a switch receives a packet, like I said, example, if you are receiving 1.5 Mbps of traffic, and maybe the available bandwidth is just 1 Mbps, now this will lead to the congestion. And when there is a congestion, then there is a possibility that the packets may get dropped. Now, while deciding whether to drop or not, this field we can be a decider. So any packet which is carrying with 0, this is the discard eligibility bit. If it is 0 means it's like not eligible to drop. But whereas if it is carried with 1, that means it is eligible to drop. You can decide the eligibility of the packets getting dropped or not based on this field. But in general, normally we don't use this at the L2, but this field is something specifically for that. Again, the other option we already know, the VLAN identifier, which is going to identify the VLAN number based on the range. The range is up to 2 to the power of 12. That 12 bits is reserved for the VLAN ID. So again, if you are using a frame delay, like in terms of layer 2, most of the time we will be using Ethernet. Now Ethernet uses the class of service, the 3 bits, as I said, and the value ranges in between 0 to 7, right? That's what it will be. So, but again, if you're using any other layer 2 network like frame delay, so we don't use frame delay in today's networks, but I'll just quickly give an idea. In case of frame delay, there will be a 1 bit reserved for that. Like we have something called discard eligibility bit, which will be carried in the frame delay frames. And accordingly, here it will be either 1 or either 0. 1 tells there is a congestion, 0 tells that there is no congestion. So depending upon the congestion, probably it's going to indicate and forward according to that. Likewise, if you're using any kind of frame delay networks, MPLS networks, in MPLS also we have a special field called experimental bits. Inside the experimental bits, again, this is 3 bits, which means you get the values same. Based on these 3 bits, you get the value from 0, 1, 2, 3, 4, 5, 6, 7. Whereas the 0 is considered as the least priority, 7 is considered as high priority. So in terms of marking, whether you are doing in the layer 2 network Ethernet or whether you are doing MPLS, the only difference is the values remains the same. But the difference is in Ethernet networks, we call this as class of service value, the cost value ranges from 0 to 7. In MPLS networks, we call this as experimental bits 0 to 7. So that's the only difference, because the headers, the different types of networks carry different types of headers, and based on that, the values will differ. But mostly when most of the time in today's network, like we'll be using either Ethernet or inside the MPLS, the name will change, but overall the values remains the same here.